All right, everybody. Welcome to today's Techie Tuesday. Today we have planetary scientist and aerospace engineer Alex Kling from NASA Ames. He's going to tell us about the seasons and the climate of Mars. So just as a reminder, please mute yourself and make sure your video is off so that we see Alex up there. So Gertrude, if you could turn off your video. Everyone else. All right, take it away, Alex.
All right, thank you so much, Cynthia, and hello, everyone. Well, first of all, as you can see, I'm a planetary scientist, and you might have a question. What is a planetary scientist? So basically, a planetary scientist study the different planets in our solar system and as a way to understand the different physical processes that form the planets and also how can they evolve. And that can be the surface, that can be the atmosphere. And I just listed a few examples here. So what you see on the top left is a view of methane lakes on Titan. And the question that always comes is like, why is it there? Why do we have methane lakes on Titan? Here's another example. This is an actual image of a polar storm on Saturn. Why do you have these processes occurring on Saturn? Some beautiful cloud structure on Jupiter. This image has been taken by the JunoCam instrument. Other fascinating, some volcanoes on Io. Io is a volcanically active moon. Some plumes of water vapor on the moon on Enceladus. And then finally, we discovered very recently that Pluto is so far away from the sun and it has haze in the atmosphere. Pluto has an atmosphere, it has glacier. For a long time, we thought that Pluto was just going to be a desolated world. But then with the New Horizons mission, we learned so much about this dwarf planet, and it's just fascinating. So you got all these incredible processes happening in the solar system, and you want to understand why. So that's what a planetary science do. A quick word about me and where do I work. So I work in NASA Ames. It's one among many NASA centers in the United States. We have just 3 in California. There is the Armstrong Space Flight Center in the Mojave, the Jet Propulsion Laboratory in Los Angeles, and then we are NASA Ames in the San Francisco Bay Area. But if you're looking for internship in the future, opportunities, you should research where are the different NASA centers is what they do, because there's a lot of them across the country. All right, so this is going to be your agenda for the day. I want to talk to you a little bit about the history of Mars exploration, like why do we care? How do we go there in the first place, and what are the main questions we're interested about? Then I want to talk a bit about the difference between Earth and Mars. Planets have many similarities and then are really different in their own ways. And I'll talk to you a little bit about my work, which is to simulate the climate on Mars. And you're going to see that Mars has climate, it has an atmosphere, and it has season. And we're going to dive a little bit into this. All right, so starting with the exploration of Mars. What you see, actually, this little map in black and white are actually earlier maps of Mars. So it was back in the day where, you could look at the sky, you would see Mars. And they had some telescopes that they didn't have very good quality because the instruments were just not as good at the time. So people could see some features on the surface, but that leave a lot of room for the imagination to explain what these features were. So they had rivers and oceans. Wow. So people will see a road. So Mars always captivated imagination. And it was not until 1964 that the United States sent a probe to Mars. It was the Mariner 4 probe to do the first flyby of the planet. So we launched a spacecraft from Earth. He flew by the planet, and he brought back the first high-resolution picture of the surface. And it was pretty much a disappointment for just the community, because it was just a dry world. There was no water. There was no aliens. And people just wonder, why do we even want to go back there and explore? But then the scientific community pushed back, and we said, okay, that's interesting. There's a lot of things to do. And so we came back. And the Mars exploration program really took off with the Viking program in 1976 and 1992. It was a twin mission. So For redundancy, they sent 2 orbiters and then 2 landers that actually mapped the planet from orbit and landed at the surface and brought back some first measurements. And then we started to realize that actually Mars is a really interesting planet and different in its own way, but there was just a lot to learn. So we keep going. In 1997, we sent a Pathfinder rover. It was a lander with a rover the size of the shoebox, and it just moved around, and then it demonstrated that we could actually operate robots on the surface of a different planet. There were some more landers, like the the Phoenix probe in 2008, the rover Spirits of Opportunity that you might have heard of, Curiosity that has been operating at the surface since 2012, and actually too many others to list them all. But you know, there was the InSight lander, the Perseverance, which is a NASA mission that's going to take off this July from Cape Canaveral and arrive to Mars at the beginning of next year. And in addition to all these surface assets, NASA and international partners like the European Space Agency or the Indian Space Agency have several numbers of orbiters that they use for communication. So when the rover takes the surface, it needs to send the image back home, and we use an orbiter as a communication relay. And we also have a lot of science instruments, and we can learn a lot about the surface and what's happening on Mars just from orbit. All right. So that was a little introduction, and now we're going to dive deeper into the difference between Earth and Mars. So by the way, what you see on the screen are actual picture of the Earth and Mars, and the scale is actually real scale. So as you can see, Mars is a little bit smaller than Earth, and then the atmosphere is different. You know, on Earth, you've got air, which is oxygen and nitrogen. Mars isn't entirely made of CO2. And it's also a little bit further away from the sun, so it's going to be a little colder. All right, so I want to start by you know, one science question that has been really driving the community, and I will invite you to think about it for yourself and maybe type an answer in the chat. So, is there water on Mars? That's the big question. So the 3 answers I'm proposing is A, no, it's completely dry. Yes, but not liquid water, only as cloud, vapor, or ice, and then C, as liquid. I see some answer coming in. Excellent. All right, we'll check the answer in just a little bit. To you about the similarity between Earth and Mars. So on the left side, I'm going to show some picture of the Earth, and on the right side, I'm going to see some picture of Mars. So Mars is Canyon. And you can see on the left an image of the Grand Canyon in Arizona. And then if you think the Grand Canyon is big, if you may have seen the Grand Canyon yourself, then you have to think again. Because on the right side, you see an image, an actual image of Valles Marineris. And it's one of the longest canyon systems in the solar system. It's about 3,000 miles across. So it's really huge. And as you could see, I put the United States as a scale for reference. And these things are huge. Mars also has volcanoes. This is again a real image of an extinct volcano. It's called Olympus Mons. It's the highest mountain in the solar system. It's about 25 kilometers high or 15 miles. And if you look at the bottom for reference, I put Mount Everest, the highest mountain on Earth, as a reference. And you see it's just a teeny tiny portion of Olympus Mons. So the geography is just dramatic on Mars and so fascinating in many ways. Now, if you look from orbit, we've been observing something very interesting with our Valley network. So you might be able to notice on the left side a picture from the International Space Station. You can actually see one of the solar panels. And then one of the similar feature we've been observing on Mars in the Valley network. So you could see this very little characteristic of you know, erosion by water. And we don't see water at the moment, but we see these features. So there must have been liquid water at the time, but now it's probably just gone. Another interesting feature of the Martian climate is dust. Mars is very dusty. They are like teeny tiny particles, and because they are so tiny, they can stay aloft in the atmosphere for a long time. And it's really one of the major drivers of the Martian climate. And every couple of years, there's a global dust storm that are absolutely terrific. The entire globe, and This is an example on the right of the 2018, the storm that has taken down the Opportunity rover. So when you have dust in the sky, then you don't see the sun. If you don't see the sun, you cannot power the solar panel. And the rover can last a little bit on, they don't do warm with so much we can do, and eventually we lose communication with the Opportunity rover. Finally, this is incredible. See on the left an image of Greenland taken from space, and on the right you have an actual image of polar caps on Mars. So they are a little different, but then on Mars, different process. They're made of CO2, so basically dry ice. So you might remember I mentioned that the atmosphere of Mars is not nitrogen and oxygen, it's CO2. And because Mars is further away from the sun, it's so cold at the surface that the CO2 in the atmosphere just condenses on the surface. So it's not made of, it's not liquid that freezes, it's really the atmosphere that just condenses on the surface because that's how cold it is. And finally, a beautiful picture of clouds. So that might be a hint to the QUIZZ we talked about earlier. You could see, again, an actual image from Mars reconnaissance or these clouds over the volcanoes. So I don't know if you could see on the middle right of the figure, we have Valles Marineris, the canyon system we just mentioned. And you could see these three little dots on the left side of the canyon, and then another big dot a little more to the left. So these are the fastest volcano we just mentioned. So back to a quiz, and I see many of these. I'm not going to count it, but I see many good answers. No, there's no, Mars is not dry. There is liquid, there is water. It's mostly as cloud, vapor, and ice. We have found some evidence of what we call brine. So brine is a mixture of water and salt. And when you add salt to water, you can actually decrease the freezing point. That's what we put salt on roads in winter. And we have some evidence for those on Mars. So there might be a briny liquid under the subsurface, but on the atmosphere and on the surface, no, Mars is just too cold and the pressure is too low. So the only water we have is clouds and water vapor. All right, we're going to move to the last part of the talk, and I want to talk to you a little bit about the climate of Mars. And I'm going to start again by a question for you. So looking back to Earth, why do you think we have seasons on Earth? Answer one, the sun is just dimmer in winter. And B, the sun is further away from the sun in winter, so it's going to be colder overall. Or C, the Earth is just tilt on its side. So I want to give you just a few seconds to think about it, and I'd like to see the answer. All right, I see some answers coming in. All right, this is going to be interesting. There are two main parameters that the orbit of a planet, and these are the planet eccentricity. So as the planet orbits around the sun, what is the trajectory? Is it more like a perfect circle? Is it more like an ellipse? Is it inclined with respect to the plane with the other planets? And the other one is the obliquity. So it's a little tilt. The Earth is rotating on its axis, but then if you look with the plane or with respect to the plane and the other planets, it's a little tilted with respect to this axis. So if you look at the orbit eccentricity, and on the blue line shows the eccentricity for Earth, the red line is show the eccentricity for Mars. You can see that Earth is pretty much a circle. So across the year, the distance between the sun and the Earth does not vary too much. It does vary a little bit, and surprisingly, the Earth is close to winter in the northern hemisphere, but it's not a big factor. Really, the dominant factor is going to be the obliquity, and I'm going to show you in a little bit. For Mars, it's different because Mars is not quite a perfect circle around the sun. It's more like an ellipse, and it does get closer to the sun and further away to the sun. So you have really these two effects that are contributing. So this is what I meant. This is a little cartoon of Mars rotating about the sun. You could see that the trajectory is not a perfect circle. It's an ellipse. So it does get closer at some point to the sun, and then it does get further away at certain time of the year. And I would like you to focus on the northern hemisphere. So I draw on the left side of the screen a little red line that shows the equator. And you could see that it's not pointing up straight. It's a little inclined. It has a little inclination, just like the Earth does. And I want you to focus on the amount of sunlight that's received by the northern hemisphere. So let's see. You could see that a little part is part of the planet is shaded, and then part of the planet is actually in the sun. Now, if you compare on the left side the pie slice of the planet that's illuminated by the sun, it's much smaller in winter on the left side of the graph than it is in summer on the right side of the graph. And these are where most of the seasons sun. So it's what's happening on Earth. You know, when it's colder in December, it's not because the Earth is further away. It's really because the Earth is inclined in such a way that we are mostly facing away from the sun. And then in summer, it's the opposite. The northern hemisphere is pointing toward the sun, so we get a lot more sunlight. And that's for the Earth. Now on Mars, it's a little different, because if you remember, it's not a perfect circle. It is actually an ellipse. So Mars is going to get closer to the sun at some time of the year, and then it's going to get further away. So when you're closer to the sun, that's what's happening on the left side. You actually have a lot of heat. That's going to be, that's going to be warm in the atmosphere. And then when you're further away, you're going to get cooler. So you really have these two systems going on side by side. One has to do with the obliquity, and one has to do with the eccentricity. We can study with models, and that's what I do primarily at NASA. So we got some data from orbiters. We can know what are the temperatures at the surface. We can retrieve the temperatures in the atmosphere. So we have a little bit of data, and we use actually climate model to try to explain and understand all the processes, similar to the one I listed in introduction, because it's a lot easier to run climate model than to gather a huge amount of data. So we have a little bit of data, we can run a model, we can verify that the model reproduce the data real well. And then because it's a model, you know, we can see the whole planet, we can simulate it at various different altitudes. So these are very useful tools to investigate the climate of different planets. So at NASA Ames, we have a supercomputer. So it's actually just a big computer. I've been to the computer myself. It's like a giant room. You could get lost inside the computer. And this is because these simulations are really computer intensive. So you need just a lot of power, a lot of processes to compute this very complicated process. Because if you want to simulate the climate, you need to simulate everything. You need to simulate the winds, the temperatures, the interaction of the infrared radiation in the atmosphere, the dust particle, the effect of clouds. So it's a very complicated system that we're trying to simulate. So think again about the season. I'm going to show you, you know, the different features I listed when we're looking at Earth and Mars and how we can explain those with a climate model. So these are the results of simulation for the model, and it's going to go across a full Mars year. You could see the little circle on the right side that shows the orbit of Mars around the sun, and then you can see all the different surface fields are changing. Three things on the picture that I want you to point attention. The first one is the CO2 ice. So it's going to be this bluish tint now it's coming out of the southern hemisphere from the bottom, and then you will see it afterwards on the northern hemisphere. So we saw that Mars has season. So at some time of the year, the North Pole is pointing toward the sun, and it's really hot. So all the polar caps are going to sublimate back into the atmosphere. And that's the first cycle. It's called the CO2 cycle. So in Mars, in winter, it's really cold. You could see that at the moment. You know, you have the CO2 is condensing on the surface, and then in summertime, everything sublimates, and then the CO2 is transported to the other side of the planet. The caps in the south and in the north, they balance out the CO2 in different cycles. Now, the second thing I want you to look out, it's shown as a little white shade, and it's the CO2 ice cloud. So if you remember, I showed some picture of Earth and Mars, and we've seen that Mars has cloud. So where does it come from? Why do we have clouds at a certain time of the year and not? So what's happened, if you look closer at the image at the moment at the northern pole, you could see there's still a white shade, and these are not CO2 ice, it's actually water ice. So what's happening is the CO2 condenses on the surface and it forms a pretty thick layer of just a couple of meters. And then underneath are buried water ice sheets. So at certain time of the year, when all the CO2 sublimate in the atmosphere, it exposes the water ice. And this water ice can sublimate in the atmosphere, and that's what's going to provide the source of water for the clouds you see. So let's look a little bit at it together. You could see now the northern polar cap is retreating, and then as it exposes, you could see this thick layer of cloud on the equator, and that's because the source for the water has been exposed. All right, I have one more thing to talk about, and it's dust. You remember I told you that Mars is a very dusty planet. And if you cycling for a year, you could see at one time it really gets bright yellow. So Mars is dusty through the year. There's always dust in the atmosphere. But what happens is that when Mars gets closer to the sun, it's a lot more hot, then the atmosphere is a lot more vigorous, and then it's a lot easier for winds to pick up surface dust. So now you less surface dust in the atmosphere, and it happens to be a very radiatively active tracer. What I mean by that is that if you have dust in the atmosphere and if it's hot, it can get hotter. It's going to get really hotter during the day and then cooler at night. So you can get even more wind, more dramatic condition, and you can get even more dust. So that's what we call a feedback effect. So there's this very particular time of the year when you're really close to the sun, it's really hot, you release a lot of dust, and that's where you can have, very, very pronounced dust activity. Back to a quiz, actually the answer is C. On Earth, it's mostly because the planet is tilted on its side, and then you have one hemisphere that gets a lot of sunlight while the other hemisphere is in the shadow. But on Mars, the situation is a little different, and it's actually a combination of B and C. So you have the seasonal effect due to obliquity, but you also have the effect of the distance, during the certain part of the orbit where you're closer to the sun and the other part where you're further away from the sun. All right, I think I might have been on time, I'm not sure. And I'd like to know if you have any questions for me. You can use the chat and maybe Cynthia can relay some of those for me. I hope you enjoyed it.
Does anyone have any questions for Alex? Since we're such a small group, you can just unmute yourself and ask him if you want.
Oh, that'd be great.
Yeah. Alex, I have one question while we're waiting. Has the climate of Mars always been like this, or has it changed over time?
Oh, it's a great question. I actually have some backup slides about it because at NASA we always try to to think ahead. So, I've showed that we have seen valley network on Mars, and we've seen evidence for a water-based erosion. So we know that back in the day there must have been some water, and we have some evidence on. So what I'm showing on the right side as what we call layered mudstone, and it's basically an ancient riverbed. So we have the rovers driving around, and they see that kind of sediment of a sedimentary structure, and that tells us that back in the day things must have been a little different, and there must have been water. Now the big question remains: where did the water go?
And could there have been life on Mars? Like when there was water?
It's a first one question. Well, people are still trying to address, the question, is there life on Mars today? Because we have example on Earth, wherever we went, we found life everywhere. You can go to Yellowstone in this big, Yellowstone has this big pool of acidic water. We found life there. We found life at the bottom of the ocean. Example where, we've sent like instrument to space, to the moon, we brought back the instrument, they still had bacteria on it. Like life is very resilient. So it's not implausible that on Mars, life could be sustained under certain condition. And it's really an open question. I think what NASA was looking for was really a trace of what we call astrobiological environment. So where the conditions good for life at Mars? And the answer is yes. We found some evidence for that. So it's a personal question. I say yes.
Okay, we have a couple more questions. So one of them, Ruchi asks, is there evidence of liquid water under the surface of Mars?
Actually, it's a very good question. And there's been a major discovery about, I want to say a year ago, it could be a year and a half ago, we found some major underground lake at the surface, and they were located near the poles. And this is quite surprising because you know it's really cold at the surface of Mars, and then we have a little model, and you can predict the soil temperature. And it seems like at the depth where we found those lakes, you know, the temperature is way too cold for liquid water. There must have been some example of brine, very salty mixture that stay there. So not running liquid water as we think of it, but definitely some type of brine, very salty mixture could be running either seasonally or in the subsurface.
Awesome. And Dia asks, is it possible to grow plants from Earth on Mars? If you're in that
You
deep.
know, aha. So you know, if you want to grow plants, you need you know, you need some sunlight, you need some fertile soil, and it happened to be that the Martian soil is not very good for growing plants. It's because it's very salty. But you know, if you process the soil, or if you bring your soil from Earth, and if you bring some water, I think you'll have to be probably very enclosed, because it's another question that I didn't touch too much into, but Mars doesn't have a magnetic field. So it's really exposed to all the solar wind and all the nasty solar radiation. So I'm not sure a lot of Earth plants would like that conditions, but and then also they will need to be in liquid water. And if you put a glass of liquid water on Mars, it's gonna sublimate, it's gonna evaporate. So they have to be in little domes, and yeah, I think they could do just well, just not at a massive scale and without protection.
Awesome. Anybody else have any other questions? No? Well, thank you so much, Alex. This has been fascinating.
Well, my pleasure.
Yeah. Thank you everyone for coming, and we'll see you next week for Techie Tuesday.
All right, bye bye everyone.
Bye.